Hello and welcome to a new lesson in our class Cloud for Devops. Today we are going to talk about Docker. You may wonder why I have this image with containers on a ship. Well, if you've heard the word Docker as far as the technology of Docker goes, you also heard the word container. They go hand in hand, Docker containers. And the notion of container in the Docker world is related to the shipping container. And there's this book I wanted to show you the box, how the shipping container made the world smaller and the world economy bigger by Mark Levinson. And in this book, he explains how this apparently simple invention of the container revolutionized transport because it was a standard way of transporting things inside the container, and then the industry came up with industry standard ways of stocking a ship like this, and then coming up with trucks that would take one of these containers and transport them from one way or another. So a whole industry has flourished around this simple notion of a container. And Docker, as far as the IT technology goes, is similar. I want to go a little bit into the history of how Docker came about. Back in the dot-com days, if anybody remembers those days, 1999, 2000, 2001, we had this type of servers, bare metal servers, as we used to call them, racked and stacked in colocation facilities. And I personally remember very well those days where I had to go into the colocation facility and wire everything together, use one of these monitors to connect the keyboard and the mouse to one of these servers and configure it manually, and then go to the next server, make sure all the wiring is correct, to the patch panel up here, and so on and so forth. It was painful. It wasn't super fun to be there in the colocation facility. So I was happy when the industry moved on from this notion of one server hosting your applications. And the next step was virtual machines, which were made very popular by VMware. In this case, you have your bare metal server with an operating system, but instead of running one application per operating system per server, you would split this bare metal server into multiple containers. And each container shown here is called a virtual machine. They are running on a piece of software that VMware wrote and every other companies wrote who are in the VM business. And the containers themselves have a full copy of a what is called a guest operating system, guest OS, with all its binaries and libraries. And on top of that little OS runs your application. The advantage of using VMs, virtual machines, over a bare metal server is that you can split one bare metal server into multiple VMs, and they can each run their own operating system if you so wish. One of them can run Ubuntu, this one can run Red Hat, this one can run CentOS, this one can run even Windows. And your host operating system, which is what is running on the bare metal server, is different. Sometimes it's made by VMware themselves. So this was the world of virtual machines. A few years ago, Docker came up with their own packaging standard, um, which is represented by Docker images and Docker containers. So here on the left, we have the situation I just described with virtual machines. You have your host operating system, your hypervisor, which is written by, let's say, VMware. And then on top of the hypervisor, you have, in this case, three guest operating systems. Well, with Docker containers, you have your host operating system, and then you have a Docker daemon instead of the hypervisor. And then within the Docker daemon, within the host operating system, you run Docker containers. And the main difference between virtual machines and Docker containers is that the containers are in user space. They run as processes as far as the host operating system is concerned. The packaging happens at the file system level, and there's also the notion of isolating one process from another with things like C groups in Linux and other technologies that we're not going to go into today. But anyway, a Docker container is a much more slimmed down version of a VM, if you want to think about it that way to kind of comprehend it. And it has only those binaries and libraries that your application needs. So let's take an example. I have here a few files, and this is a Mac I'm on, and I will show you the app.py. It's a Python application based on Flask, and this application also uses Redis. And what it does is it counts the number of times the main page, the home page, has been hit, and it displays that on the home page. Very simple application, but it will be useful to show it in terms of Docker. So what you do with Docker, you take an application like this and you package it up into a Docker image. A Docker image is represented by what is called a Docker file. So the Docker file looks a little bit like a shell script, and it tells Docker what it needs to do in order to package your application and all the necessary prerequisites. So I have here a requirements.txt file containing two Python packages, Flask and Redis, and they will be installed inside the Docker image. Here on my Mac, I have Docker running, and this command, Docker images, shows the images that are currently here. So as you can see, I have no image. To build a Docker image based on a Docker file, you run docker build -t, which means I'm going to give it a tag. I'm going to call this image somehow. So I'm going to call it my app, and then I'm going to say where is the directory that contains the Docker file. In this case, it's the current directory represented by dot. So if I run this command, you will see that the Docker engine starts building things inside the Docker container. It uses a base container, a base image containing Python 3.7, and it pulls it down from Docker Hub. And then within that image, it runs pip install, and then let's go back to what it does. So it adds the current directory represented by dot to /code inside the Docker image. Then it changes directory to /code, and then it runs pip install -r requirements.txt. As you can see here, it added dot, it went to /code, and then it ran pip install, and pip install downloaded Flask and Redis. Then it runs a command, python app.py. It will only run this command when we actually run the Docker container. So now if I say Docker images, I have two images on my laptop. I have Python, which was downloaded because, if you remember, that was the first line in the Docker file. It said use Python 3.7 Alpine, which is right here. And then it has my app, which has the tag. If I don't give it a tag, the default would be latest. So now I have a Docker image on my laptop. However, once you start with Docker, you will find that usually you have to have the Docker containers talk to each other. And you'll need something like what people call an orchestration layer, which in our case is Docker Compose. So Docker Compose is another tool from the Docker ecosystem, which ties together several microservices. In this case, there are two of them. The first one is called Web, and it contains our web application. The second one is called Redis, and it contains the default Redis Alpine image. As you can see, the Docker Compose, which I got from a Docker Compose tutorial, will actually build the container again, the web container again. So let's do that. Docker Compose up is the command, and this will provision both containers. So right now it is doing the build again of our web application inside its own Docker container. And it also builds and it also downloads and runs the Redis container. So if I go to a new tab and I do Docker images, you can see that now we have Docker Compose Demo Web, which is our web application, and we have Redis. And if I do Docker PS, which shows me the currently running containers, you can see that there are two containers running. The Docker Compose Demo Web container containing our web application, which has Python app.py as its command line, and Redis Alpine, which simply runs Redis. They were both created 29 seconds ago when I ran Docker Compose up. And very importantly, for our web application, it shows what ports are being used. And here it says that port 5000 on my local host goes to port 5000 inside the container. So let's verify that. If I go to localhost 5000, sorry, I see hello world. I have been seen one time. Then if I hit Control R, you can see how the counter gets incremented. So this, in a nutshell, has been a short presentation of Docker and Docker Compose. The nice thing about Docker, though, is that it is very portable. One main advantage that we've already seen is that we managed to build a Python-based web application using Redis without actually installing either Python or Redis on my laptop. Everything was installed inside Docker containers. And this is very powerful. There are Docker images for all the major pieces of software out there. If I want to run my SQL on my laptop, I can run it inside its own Docker container, and I don't have to worry about installing all the prerequisites for my SQL. So this packaging aspect of Docker is extremely important. It took me a while to figure it out, but once you understand how powerful that is, you'll be hooked. What I have here is a Amazon EC2 instance that I launched recently, and it's running the Amazon AMI for Linux. And as you can see in the history, I installed Docker, the Docker engine. I'm logged in as the EC2 user. So here as well, I can run Docker images, Docker PS. There's nothing there. So let's do this. Here I am on my laptop. I run Docker images again, and I want to push this image we built called my app. I want to push it to Docker Hub. I have my own username on Docker Hub. Anybody can get their own username. So first, I'm going to tag it, Docker tag my app. I'm going to tag it as my username / my app latest. And then I'm going to push my username / my app latest. And by doing Docker push, if I don't do anything else, by default, it goes to docker.io / my username / my app. So right now, what the local Docker daemon does on my laptop, it pushes everything to Docker Hub. The push ended. The reason why I want to do that is that I want to scp Docker Compose demo, this whole directory, which contains my Docker Compose files, to my machine here. Here's a nifty way for you to find out the external IP of an instance. If you curl ipinfo.io, it gives you the external IP. So I'm gonna use a specific SSH key. So I'm gonna copy it to EC2 user at this. Okay, so let's go back here. Now I have my Docker Compose demo. It contains the same files we saw on my laptop. One thing I want to do here is, instead of saying build, I don't want to build another image. I want to reuse the image which I uploaded in the previous step. So as you can see, for the web application, I'm using the image that we built and packaged on my laptop. So let's try Docker Compose. Oh, I may not have Docker Compose actually. Okay, let's see if I can yum install it. Okay, that didn't work. A quick Google search showed me that I actually have to download it. So I'm downloading it here to use a local bin Docker Compose. Let me change it to executable. And now let's try Docker Compose up again. As you can see, it is pulling my container, my image. By the way, the difference between a container and an image is that the container is the running expression of an image. The image is the static representation of Docker containing the binaries and the libraries. And when you actually run it, it becomes a container. So here it pulled the image, my username / my app, and it attached and it pulled Redis. So now if I go again to, in a different window, if I go to my box, if we do Docker PS, we'll see 39 seconds ago these two containers were created. If I do Docker images, we'll see the two images here. And we can also see that if I go to the IP of the box, this IP, external IP on port 5000, I should see my web application. So let's make sure that's the case. That doesn't seem to be the case, so what I had to do was allow port 5000 on my EC2 instance in the security group attached to my EC2 instance. So now let's try it again. There you go. We see that I can hit the same exact web application, which is now running on my EC2 instance. So what we did is we packaged the web application on my Mac. We pushed it here to Docker Hub. Then in the Docker Compose file, which I can show you to here, one sec, Docker Compose demo, we used it, we tied it to Redis as on my Mac, and now we can use it. So now, I was able to show you two very important features of Docker. One of them is the packaging aspect, in that if we look at the Docker file, we installed Python and the required libraries inside the Docker image, not on the box itself, and also the portability. Any box that runs the Docker engine or the Docker daemon is able to run our Docker containers. This just scratches the surface of what Docker can do, so I am going to continue in another lesson with other more in-depth presentations on Docker and Docker orchestration and various things that tips and tricks that you can use when you use Docker. So stay tuned. See you next time.